Hello CIS27. I wanted to go over week 3 materials in this video. For week 3 we will need to compare and contrast different types of attack. We will work on understanding the network technologies and components and looking at how to solve some of the security issues and utilize secure protocols to implement network architecture. So in this week we are to read chapter 3, complete the assignment, and complete the lab, which is linked to practice labs. There's also an extra credit review game which will help you prepare for next week's quiz, and the winner of that game will earn an e-gift card. So for this week you can begin with looking at the notes and the chapter content. The notes you will find on the second page of the module, so you can download this or view it within the page. So in our notes, we will talk about different type of attack, beginning with sniffing attack. And in the sniffing attack, the attackers would use protocol analyzer to capture the data over the network. A common tool that's used in this particular form of attack is a network sniffer, such as Wireshark. And there are other types of network sniffer that's being utilized, but Wireshark is a common one. So in the later lab, you will be utilizing Wireshark on the virtual machine environment. Now, a lot of the things that are listed on the first page of the notes include the security tools that one would use to test the network or to analyze the network. So the first one is going to be Wireshark. As I mentioned, it's a network protocol analyzer. So whenever that a system is connecting to the network and accessing resources or communicating with the rest of the appliances, the network infrastructure, and even accessing the internet, Wireshark as a network protocol analyzer is able to sniff out some of the traffic or present some of the traffic. So we're able to see the logs of different type of traffic, from the computer system to switches to routers, etc. Now the security tools, you can find this on securitytools.org or sectools.org. And the first one, as we list, is the Wireshark. It gives you some details about it. You can also find the link to be able to download for different operating system and use. And on this page, you would see that there's different type of tools, such as Metasploit, and Metasploit is now can be utilized with Kali Linux. And Metasploit is often used, especially when we're analyzing our systems, to test our system to see if there is some issues with exploited code. Okay. Another tool that you would also see that's commonly used is Nessus, and Nessus is often used for risk assessment, and it's, for the personal version, you're able to get it for free. However, the pro version requires a very expensive license key. So the Nessus Home or the personal release, you're able to download it to be able to assess. And what it will do is it's going to take a look at the connected system and look at the vulnerability and also the risk in the system. So first it's going to do inventory of the systems that's in the network. Then it's going to identify specific areas of the system that would have the potential risk. So Nessus is also a good tool to practice on. Aircrack is a suite of tools that allows you to test the algorithm of your wireless keys. And the attacker would use this type of tool to break wireless encryption key to be able to access the wireless network. Aircrack is now equipped with Kali Linux, so if you use Kali Linux for pen testing or practice purposes, you would find that you will be able to utilize some of these tools that's already built in. So similar to what you see with Wireshark, Snort provides the protocol analysis component along with packet logging and looking at potential issues that's on the network. So Snort been around for a long time. However, you're able to find the later release, and which was established years ago, but you can download and be able to practice Snort as well. Cane Enable, there is also a lab for Cane Enable in Practice Lab, which you will see later. And Cane Enable is used on Windows environment to test password strength and encryption key and also analyze different type of traffic. It has some additional tools that's built within, but often people use Cane Enable to test passphrase, password using brute force or dictionary attack, and also crypto analysis attack. That's what it will be used for, is to test it, or from an attacker standpoint, they would use it to break password or to break encryption key. Backtrack is an older version of what we see with Kali Linux today, and Kali Linux is the newer version. However, you'll be able to find other Linux releases that would have the tools, the scripts, and people would utilize it to be able to test their systems and their network. And as you go down this list, you will find additional tools such as Netcat, TCP dump, John Ripper, Kismet, and other types of tools for different purposes. So this is helpful, especially when you are beginning to learn what type of tools that you can use to be able to assess and understand the security issues in your system and your network. So on the first page in your notes, you will find the similar list. And again, you can refer to the website, which is sectools.org. Now, the second attack that is mentioned is a very common form of attack. DOS stands for denial of service, or DDoS stands for distributed denial of service. The main difference between DOS and DDoS in that distributed denial of service, the DDoS, utilize multiple sources to be able to attack one target, where distributed denial of service is going to use a single source to be able to disrupt the services. So for a company that has web server, when they face denial of service attack, what happened is their services would be disabled, their websites would go down, none of their customers are able to utilize their web services. So we wanted to be able to implement monitoring tool like Wireshark and additional security tools to be able to detect some of these forms of attack. And so companies would use intrusion detection system, firewall, and other security technologies in order to prevent attack from happening and also detect attack when it occurs. The third type of attack listed here is a form of poisoning attack, and it comes in different type. And poisoning attack in general uses protocols that's stored temporarily in the memory, in cache. And to access that, they usually have to be able to sniff out what kind of traffic and then identify the area where the data is cached to be able to modify some of the data and corrupt the cache in the case where they want the user to not be able to access the data on that system. And poisoning attack goes from, cookie poisoning, which is related to internet websites, all the way to our poisoning, etc. So we'll go in depth with some of the poisoning types down the line, but for the quiz and the exam, we wanted to focus on the category of attack, which has been mentioned on page 1 of your notes. Now, understanding security, it's essential to have a good foundation of networking. Outside of this class, I recommend you take CIS40A, which is offered at Moreno Valley College, or you can take CIS26ABC at RCC. Now, in security, we regularly work with networking protocols. So in this part of the lecture, I wanted to go over the network protocols. All internet traffic and all our traffic that's generated from the system, our network traffic, generally falls under TCP IP. IP is used for addressing, and it would pinpoint which system is communicating with an IP address. TCP is used for connection, and TCP does a three-way handshake where it does a confirmation. TCP stands for Transmission Control Protocol, and in the three-way handshake, there's acknowledgement that's happening where the connection is established. So in the first step, it does a synchronization with the packet. Each system, when it's communicating and sending data, it sends a packet. And in that packet, it would have a header where it would points back to which system is sending the packet and where is that packet going to, which is the destination. So in order for that packet to arrive to the appropriate system or the destination, using TCP, it establishes three-way handshake. It synchronizes the packet that is sent from the host or the server, the system. Then it's gonna establish the confirmation of the recipient or the destination that's gonna be ready to receive the packet. Once the confirmation for the destination is received, then the client, which is the host, will be able to acknowledge that the connection is established, and then the packet's gonna be transferred. So in TCP, it does take a little bit longer time, as in it has to establish the synchronization, the acknowledgement or the confirmation in the communication channel between two systems in order to send. Now, unlike TCP, UDP stands for User Datagram Protocol. It is connectionless, and it delivers traffic without additional confirmation. In the denial of service attack, often that they would capitalize on UDP, in which there's no confirmation, there's no reassurance in that traffic being or the communication being established in order to send the packet. And UDP is often used for media-based services like video, streaming media. The packet would open as it arrives. Compared to TCP, the packet would reassemble and not be open in pieces like UDP. So in TCP, the packet would fully be reassembled and then it opens. So comparing the two protocol between TCP and UDP, TCP takes a little bit longer in as far as time for delivery, but it is gonna be a little bit better in such that, you know, it acknowledge and it's gonna make sure that it arrives to the right destination. Where UDP, it's gonna open as it arrives. So data is sent in an unorganized manner. So when a packet goes to the destination, what you would see is that data would be raw. And for TCP, it needs to reconstruct the entire packet and organize everything that's going to be in sequential process to deliver the data, to present the data to the system. Where UDP, as the pieces arrive, it would then open it up and be able to present it. So this is why sometimes when you have a lag in video streaming is because the data is still arriving. It hasn't completely fully arrived, so some pieces are still going to arrive and it doesn't necessarily arrive in an orderly manner. As I mentioned before, IP is used for identifying the host, the source, and the recipient. And there are two forms of IP addresses. The IP version 4, which is a 32-bit address, and the IP version 6, which is 128-bit. And in IP version 4, it uses octets to represent 8 bits, and there are 4 of the 8 bits. So decimal number is being utilized to add for the IP version 4 address, such as if you look at an address, it would be 10.10.0.1 or 192.168.0.7, for example. And you often see the 192.168 address, that class of address, being used for home, like your home network, compared to the class A address for version 4, which is a lower number, and we'll touch back on this, in a larger type of network, like for business, organization, enterprise, because the lower class address, the class A address, you're able to have more addresses for your systems compared to the other class, which is class C, where you would have less number of addresses to be utilized for system. And in 2011, worldwide, we ran out of IP version 4. So they implemented IP version 6, which uses hexadecimal, and the address space is larger, so it's 128-bit, so that way we would have more addresses would be used. Okay. Now you have to understand that for our networks, everything inside our network uses private IP address, and it's only internally used. That means that it's used for administration within that local area network. Now, all companies' systems, including your smartphone, use a public IP address, and the public IP address is given by your service provider, and they were granted a range of addresses from an organization, IANA, and they keep track of public IP addresses, DNS number worldwide. So for the systems or for organizations to receive a public IP, they have to be able to obtain that from an internet service provider or a communication company that previously obtained that address from the IANA organization. So IP version 6 is currently in use. It's used to manage the system within the network. For the public IP, it's also used for communication worldwide. So now we're going to get into Icmp. And Icmp is used for internet. It's known as Internet Control Message Protocol. It's used to test the basic connectivity. So we would be able to ping a certain address. Now I'm on my Windows environment, and last week I mentioned that I will go over the command prompt a little bit. So in my Windows environment, I can simply do an IP config, And in Linux environment, you would do an ifconfig, and if you do a /all, you will be able to see your IP addresses. Okay, so the IP version 6 address would look something like this, and the IP version 4 address would look something like this. Okay, now when we do an IP config all, we would be able to also obtain the DHCP, which is Dynamic Host Control Protocol. This protocol is used on the server to distribute IP address, and for your home network, your wireless router at home is in charge of this as well. It has an additional role in addition to routing your traffic from inside the network, outside, and back in. It's also giving out IP addresses for all the connected system, like your tablet, smartphone, smart TV, etc. Then you would also see different leases in the addresses. Okay, and it tells you when that lease is expired. So once that lease is expired, what you would see is that the system would obtain another address. It could be the same address or a different address depending on the availability. So the Dynamic Host Control Protocol, the DHCP, what it does is it allocates the addresses based on availability. What's available in that network based on either version 4, the classes of address, and the scope of the addresses. So in a network environment, like an enterprise environment, they would set up different ranges of addresses to be able to control, which systems from which segment that's going to be connected to which part of the network. So as you can see, you also would see DNS, which stands for Domain Name System. And this is the larger network, and often you would see that it would have the domain information ending with .com, .org. So at the root level, you would see .com, .org, .edu, etc., .io, and all the web server, the website that you visit is hosted on the web server, which is connected to the domain name server. And under the domain, you can also have the child. So looking at this, you can see that the parent domain is this one, rr.com, and the child domain is the domain under that parent domain, that will be SoCal. So in an organization like a communication company, they would use rr.com for the parent, and then they would have SoCal for the child, NorthCal for another child, and so forth. So that way they can maintain the subdomain within the parent domain. And the DNS job is to take the domain name and convert it to IP addresses. So ultimately, all the systems are given IP addresses, whether statically, where we would manually put in the IP address and it doesn't change, or dynamically, where it would change due to the leases. So the domain name is going to reference the name of the domain to a specific server addresses, so that way it can resolve it. So when you connect to youtube.com or google.com or even Canvas website, right, there has to be a DNS in charge of hosting to be able to maintain the translation between IP and the domain name. And then when you have the web server, its job is to host the site content, the site information and the data, and that would link with the domain. And in addition to that, you would see most companies would use a database that would link to the web server. along with the domain in order to maintain the data that's inputted by the user or accessed by the user. So in the content of our notes, it briefly introduced how we would be able to utilize this protocol and what they are. Now for the command line, you can also ping a certain address. So we can say .0.1, for example. So when you ping an address in Windows environment, you simply type in the ping command and you would put in an IP address. Now in this case, I'm pinging this particular system, and for Windows, it's gonna send out 4 requests, and it's using Icmp, which is a protocol. So there are 4 requests for that system to reply. And once that system receives each of the requests, it's going to send back 4 individual replies. So when you see the reply like this, it would be that the system is connected. It's able to receive requests from another system. So we wanted to check to see. So 4 packets were sent with the request, 4 was received, and 0 is lost. So when you receive a timeout, that means that the system is not responding, possibly that it's not connected, or it's occupied. So we would be able to test using ping. Now in Linux, when you're trying to do a ping, you can do a ping count. Otherwise, it will continue to ping forever, right? So you would use a ping with an option, for a number of time that you wanted to ping, or you wanted to ping, with different type of options using that IP address. So that kind of shows you how Icmp is used. But then we also see that denial of service attack can capitalize on Icmp. Somebody can ping your web server forever, and it's so busy responding to the ping that it would not be responding to other hosts. Sometimes you would see this as a replay attack, but the nickname for that would be a Smurf attack. So now if we do a trace route, so trace RT, and we put in a website. Let's say we wanted to put in mvc.edu. What we're doing is we're also using Icmp, and we're following the traffic from my system to the domain morenovalleycollege.edu, so through the routers. Okay. Now, in some network, they would block ping, or they would block some of the commands being used for Icmp for protection purposes. Okay. Now, when you see request timeout is when it's not receiving response from different hops, which is the router, right? And it will continue to do that, and eventually if it doesn't receive anything, it's going to prompt us some details that it's not able to respond. But traceroute is a good way to see if your traffic can go from one system to an external domain or to another system. So we can do a traceroute with an IP address, or we can do a traceroute with a domain name. Okay, so now to block Icmp, this can be configured on host-based firewall, which could be a software like Windows Firewall, or it could be configured on a firewall appliance, which is an actual device that's in the network, and we can also set that up with the router where Icmp traffic will be blocked. And when it's blocked, you would see that it would have request timeout shown. The next protocol is ARP, and ARP stands for Address Resolution Protocol. It resolves IP version 4 address to the physical address of your system, which is of the network interface card, which is media access control, MAC address. So how can we tell whether it's an IP or a MAC address? So when you look at this, for the physical address, it will be shown like this, and that will be a physical address of that particular system. And in this case, it's shown for my VirtualBox client, for my hypervisor. Now, the DHCP, that's enabled, but the MAC address is given here. The IP address is shown with the version 4, and also it has a subnet mask, and this subnet mask is used like a zip code or an area code. It's able to pinpoint what part of the network that system is accessing the data or is sending traffic. So now the default gateway, usually that will refer to your router. So if you look at the IP version 6 address compared to the physical address, it's slightly different. So IP address uses colon with the hexadecimal value, and the physical or the MAC address uses hexadecimal with the dashes. So you can see the difference in the addresses there. So with ARP resolves the address to the media access controller address, to the physical address. So it takes IP and it translates it to the MAC address, which pinpoints which system is communicating, right? Because the router, its job is to route traffic to the network and from the network. The switch is used to switch to a specific segment of the network. So it's going to take the packet, it's going to bring it to a specific area of the network, and it would use a table for MAC addresses to be able to find that system. And during that process, what we would have is we would have ARP, and ARP allows us to identify the individual hosts based on the IP translated to the physical address of that system. So all network interface cards, which is where you connect the Ethernet cable or wireless interface card, is assigned, right, statically with from the manufacturer, the MAC addresses. So the manufacturer of the system or the network interface card or the wireless card actually assign the MAC addresses, and it doesn't change. Now, in some form of attack, they would spoof the MAC address in that they would try to use a fake MAC address. But with the spoofing process, we gotta make sure that it's the address is being used across different part of the network is seen as a specifically assigned address. Otherwise, it defeats spoofing purposes. So another form of poisoning is an ARP poisoning. And in the ARP poisoning attack, the packets that's distributed to the client would have the false MAC addresses. So it redirects traffic to a different system. And so, you would see ARP poisoning being used with man in the middle, with impersonation for escalation of attack. So when an attacker attack a network, they would have they would perform different type of attack in order to be successfully accessing that network. So when you're defending your network, you should expect that somebody might, attack using ARP or ping, Icmp. or other type of protocols. So any type of services that are happening in your network is related to a protocol. And in order to protect your system and the services, we have to understand the protocol. Okay, so for Security Plus and Network Plus certification with CompTIA and other type of certifications that are related to IT and networking and security, you should try to understand and be knowledgeable in the protocol area. NDP stands for Neighbor Discovery Protocol, and this allows us to auto-configure the device using IP version 6 address. It's used for discovering devices using IP version 6 by devices like router, like your wireless router at home. It has the NDP. So router does, what it does is it's trying to see which other router is close to it that's going to be available, and it would pass it based on that. And it uses the protocol Neighbor Discovery Protocol, which is NDP. Real-time transport protocol, this is used to deliver audio and video over IP networks, including video conference like Zoom. So you would see that Zoom utilizes real-time transport protocol, or when you're making phone calls at home, because we use digital network to incorporate voice communication. So voice over IP is used across the United States. So VoIP is used with the real time, and streaming media, video teleconferencing like Zoom, push talk devices. Back in the day, there would be Nextel, and they would have these push talk radio / cellular phone device, so that way you can quickly push and talk and send that message to the recipient. So that is also using the real-time transport protocol, your RTP. Next, we're going to talk about Secure Real-Time Transport Protocol, which is the enhanced version of RTP. This provides encryption and message authentication. So in the later technology, you would see, especially with video conferencing and communication with voice, you would see the integration of Secure Real-Time Transport Protocol being used. File Transfer Protocol, this allows the system to transfer file from a source to the destination, and we often see this with uploads and downloads of large files. There are existing FTP servers, some are free and some are not, like Mozilla is one of them. And so with that, for FTP uses port 21 and port 20 for file transfer. So, and to upload and download, it utilizes port 20 for TCP for the data, and port 21 basically to control signal. Now, TFTP is Trivial File Transfer Protocol, which is another version of FTP. It uses UDP instead of TCP. So all of these protocols that we talk about, they are assigned a number, which is a port number, and that number is gonna tie to the physical connection of that system for a certain service, like file transfer, ping, to do teleconferencing. And each of these protocol is either categorized in TCP suite, which is more stable and connection oriented, or it would categorize under UDP suite. And sometimes you do see a protocol that will be having both. So when it's connectionless, it would be under UDP. If it's connection oriented, it would be under TCP. Another protocol we should talk about is SSH, and SSH stands for Secure Shell. This is used for encrypting traffic and often SSH is used to remotely connecting to a certain system. Administrator would use SSH to connect to their server, and in order to establish SSH, you can enable the services and authenticate using an encrypted key. All the recent technology uses RSA key, or you would use a software tool to be able to manage the connection to that particular system and the key. And a common type of software tool is PuTTY. So you would likely see SSH and PuTTY in a later lab for this class. For SCP stands for Secure Copy, and this is a different version stem from SSH. It's used to copy encrypted files over the network. So sometimes you would see that administrator or technicians or user would use SSH to connect to a certain type of system, and then from there they would use secure protocol or secure copy protocol to be able to transfer file, right? For maybe maintenance reasons, updates, etc. Okay. SSL is Secure Socket Layer Protocol, and this is originally a primary way to protect HTTP traffic used to implement HTTPS. Now, SSL version 3 is it has a fix, the Heartbleed fix, that would reduce the risk in web traffic. However, it does have some encryption and it has some flaws with the original design. So SMTP and Ldap uses SSL, especially for things like when you're authenticating to an e-commerce website to make a purchase, or when you're processing transaction online for banking. You would see the encrypted traffic being implemented in the authentication process and in the connection with that particular site. Now, SSL has risk, so most organization has transitioned to use TLS, which is Transport Layer Security. This is the replacement of SSL. So instead of SSL, to support HTTPS, we implemented TLS, which is Transport Layer Security. And many of the protocol uses TLS, including Start TLS. It's used to upgrade an unencrypted connection to an unencrypted connection. So if you want encrypted connection, especially for web traffic, you would want to implement TLS. Ipsec is used for remote access and VPN reasons. So Ipsec is used for virtual private network, and it stands for Internet Protocol Security. This established a tunnel and it has encrypted IP traffic, so it protects the traffic so that way it's not visible to scanners. It encapsulates the traffic using encryption keys. So down below you would see an image of what it would look like with the header. So we would have the address header, and it would also add an AH and authentication header. And with the authentication, it would establish a session so that way the data would be transferred, an encrypted session. And so in the process is that it would communicate, establish the connection, authentication to issue the key. Then it would build a tunnel mode. It would generate a tunnel mode in which packets is transferred based on authentication. Okay, so this illustrates on how IP version 4 compared to version 6. So in addition to the upgrade, we would see that there's extensions with the version 6. and how that would be built into the tunnel mode when IPsec is used for virtual private network. So VPN is often used for secure connection, from accessing data on the internet to transferring data or performing work remotely from home, etc. And on the next page, this illustrates what a header would look like, what's consistent inside a header. So in any packet, as I mentioned before, you would have a header, and think of it like a mailing label. And in that header, first, it would be able to have some kind of protocol type that's used. So this is why when they scan the network or analyze the network, it's able to see what type of service that you're using based on the protocol. It would have checksum in order to make sure that there is some the content of the data and the packet is intact. Then it would also have a sequence number, and for TCP it relies on the sequence number to be able to reassemble the packet. In addition to that, key would be implemented for something like IPsec. So now this header also contain who is that going to, which is the source, and where is that going to, the destination. So think of it like a mailing label where you would have from and to addresses, and then possibly, the weight of your package and things like that to be able to ship it. So here it shows you a little bit of information about the header. Another protocol that we can talk about is secure file transfer protocol. So to be able to protect FTP traffic, they later implemented secure FTP protocol or file transfer protocol with the encrypted technology. So this protocol uses SSH, and SSH uses port 22. So it is an addition protocol that encapsulates or it includes SSH for communication and for file transfer. So after this, we would touch on email and web protocol. So when you're using email, there's specific protocol being used. So the first one is SMTP, and this stands for Simple Mail Transfer Protocol. It's used to transfer mail between the client system and the server. This is what you would see with Microsoft Exchange or mail type of server, where the server would receive the mail and then it would distribute the email to the specific system based on authentication. And SMTP uses TCP port 25. Also, an unofficial port with SSL for web-based server exchange would be port 465. And if you implement TLS, which is more secure for web-based mail exchange, that would be port 587. Now, the next protocol is POP3 or Secure POP3. And POP3 stands for Post Office Protocol version 3. It's used to transfer emails from server to client, especially the web services email, like your Gmail, your Yahoo email, Outlook.com, etc. But Outlook.com also supports SMTP for companies that uses email exchange server. So the secure POP3 is an enhanced version of POP3. It encrypts traffic using SSL or TLS, and it uses port 995. Okay. Now, MIME is a standard which extends the format of email messages to support text in character sets other than ASCII. So when you receive email that has ads or that has graphics or it has emoji, right? That actually uses MIME, multi-purpose internet mail extensions. And before, long ago, when email was first implemented, everything was just text. There was no additional decoder for other type of character sets outside of ASCII. Now, email messages with MIME formatting typically transmitted in using SMTP or POP3 or Secure POP3 or even IMAP, which stands for Internet Message Access Protocol, which is also being implemented for your webmail like Gmail, Yahoo, Outlook.com, Live.com, etc. When you visit a website, you're using HTTP or HTTPS. And HTTP stands for Hypertext Transfer Protocol. It transmits web traffic on the internet and intranets. Web server uses HTTP to transmit web pages to client web browser, and hypertext markup language is used to display the web pages. So in our assignments, coming back into our assignments here, we can first answer the first question. What is a sniffing attack? We mentioned that it utilizes scanner to determine network traffic, protocols, and ports. The two applications for number 2 that uses network sniffing is Wireshark or Ldap, or you can pick any of the two that is listed on the notes, page 1, or you can go to the website and look at the tools of your choice. For question 3, what protocols are often used in denial of service attack? You often see UDP, which is User Datagram Protocol, as UDP is connectionless and it doesn't do acknowledgement compared to TCP. For question 4, between TCP and UDP, which protocol provides delivery assurance? And we mentioned that Transmission Control Protocol, or TCP, does a 3-way handshake where it synchronize, acknowledge, and confirm. For question 5, why is Address Resolution Protocol important in networking? It's because it's used to identify the correct host or the system of the network so the packet can arrive to the correct system using the physical address, which is the MAC address. So it's able to convert IP to MAC. Then for number 6, which protocol performs auto-configuration of device IP version 6 addresses and discovers other IP version 6 devices on the network, such as address for the router? And that is your Neighbor Delivery Protocol, which is your NDP. And we mentioned that the router uses this to look at other routers that are available that's nearby. For question 7, which protocol is used to stream video over the internet? And that would be your Real-Time Transport Protocol, your RTP. And this is used for voice over IP to make phone calls, or it would be used for media streaming, video conferencing, etc. For question 8, what ports are used by FTP? And it uses 2, port 20 and port 21. 20 is for data transfer and 21 is for signal detection. What protocol is used to secure HTTP traffic? And for the older protocol, that will be your SSL, Secure Socket Layer. Later on, we implemented the replacement for SSL, which is TLS. And that would answer number 10. What protocol is used in place of SSL? That would be your TLS. For question 11, what protocol under the TCP suite uses port 22, and that would be your SFTP. For number 12, what protocols are used for email services? That will be your SMTP, Simple Mail Transfer Protocol. It also uses IMAP for the internet-based mail, POP3, also used to do web-based delivery of email, and MIME is a standard that would allow you to include HTML and other encoding format into the email. Now, in the next question, it asks you what is the primary difference between IP version 4 and IP version 6 addresses. So at the beginning, we mentioned that IP version 4 is a 32-bit address. It uses decimal notation, and decimal numbers are your counting numbers 0 through 9. And then it would increment by 10 each time. The IP version 6 is 128-bit. It uses hexadecimal notation, which is base 16, which allows us to have more addresses using IP version 6. For number 14, what is the purpose of a DNS? It is used for domain name resolution to be able to identify host names to IP. So as you can see, this really highlights some of the protocols that we're covering in chapter 3, and you can refer to the notes on the chapter content. And understanding the protocol is going to help you understand how all the elements of security needs to be incorporated, what type of systems uses certain type of protocol, or what kind of services would use certain type of protocol, etc. So next we're going to talk about directory services, because this is going to come up on your quiz, your final exam, and your certification exam. In Windows environment, it uses Kerberos, and Kerberos is used for authentication protocol as an authentication protocol in Windows domains. And with Kerberos, it requires that there is a key distribution center, which is a role for the server to distribute the key. It would issue the timestamp tickets, and I think in the last lecture I mentioned that on how that would be used, referring to an example of the amusement park. Kerberos use UDP port 88. Now with the authentication for Windows environment, you would see Ldap, and you saw this in the lab for last week, where you would access the Active Directory users and computers on the server virtual machine to be able to create user accounts and set up the password policy for a specific group of user. So Ldap stands for Lightweight Directory Access Protocol. It is used to communicate with the database that contains users, objects, and computers. So that way we can maintain the authentication and set up the requirement for authentication process to manage our access. Now in Ldap, it provides clear syntax for object identification like username or system name or host name. Ldap encrypts data using TLS, that will be TCP port 636. It also uses TCP port 389. So when you're looking at your network monitoring tools, when the user accesses their account and authenticates, the server is going to respond utilizing these protocols, especially if you're looking at TLS, which is used for web authentication or web traffic. or in the network environment, it might use this TCP port 389. Now, some administrator would use uncommon port, and they have to specify what that port would be resolved under what type of service. In network, time synchronization is important. We wanted to synchronize our systems for backup reasons, for updating of our policies, for data transfer, for transaction processing. There are endless reasons for us to synchronize time. And from a user standpoint, at home, when you have time change, when we roll back an hour or roll forward an hour, you are connecting your smartphone to the internet service provider, or you are connecting your smartphone to your mobile provider. And in their network, they implemented the protocol to synchronize time so that way it would be same across for all their system, including your system. So simple network time protocol is used for time synchronization. We also use NTP to sync time on the network. Now, in the network environment, we always revert back to managing our system using IP addresses on how it would be connecting or joining the network. And we would use IP addresses to identify what system is communicating, what system is down, what system is facing attacks, etc. So the organization that assigns IP address is IANA. That's for Internet Assigned Number Authority, and you can visit iana.org for that. For some additional information, they're also in charge of DNS numbers and information. And also AS, which is for the autonomous system, which routes most of our traffic worldwide. So IP version 4, we mentioned earlier that it is 32-bit IP address. It uses decimal format. There are two types of IP, public IP, which is lightly controlled, and public IP is assigned to service provider in ranges, so they would use that to distribute it to their customer or their user. Now, organization, like a business, when they establish a network and they would acquire a public IP for their network from internet service provider like AT&T, Time, Spectrum, Frontier, etc. Private IP addresses is used to manage system internally inside the local area network, and administrator would be able to use this to be able to manage systems from printers to phones, etc. Now, IP version 4 is broken into 4 classes, but there are only 3 usable classes. Class A, Class B, and Class C. So when you're looking at the IP address, if the number starts between, the first number starts between 0 to 127, like this, the first number here, the first octet, we call it, right? If it falls under 0 to 127, that will be Class A. And by default subnet mask, that will be 255.0.0.0. And this mask is it's used to identify network segment. So using Class A, you're able to have 128 networks. And out of the Class A, we can assign 16,777,216 addresses. With Class B would start with a higher first octet. So for example, if we start at 129, that will be Class B. and class B goes from 128 to 191 for the first octet. It uses default subnet mask 255.255.0.0. And with class B, we're able to have a little bit over 16,000 networks and a little bit more than 65,500 addresses. In class C, which is what you see with your home network, your first octet would start from 192, and it can go all the way up to 223. So, and what you would have is the default subnet mask of 255.255.255.0. And the number of networks that we can achieve are little networks of approximately over 2 million little networks. And in each network, you can have up to 256 systems connecting. So with the addresses, this is kind of like the layout of your octet and your subnet mask. Compare version 4 to version 6, you would see how version 4 with the class 4 addressing and version 6 use slightly different structure in that, number one, it uses hexadecimal and it has a lot of auto configuration feature. So what you have is you would have similar to the classless address in IP version 4 with the prefix, but the host, it uses interface ID, and that will be the hexadecimal value. So below that, you would see the explanation and the illustration of IP version 6. And slightly different than version 4, we have less components in the IP header. In IP version 6, you have the version number, the traffic class, flow label, payload length, header, and hop limit. Compared to version 4, it has version, header length, type of service, all these additional component, time to live, protocol, header checksum. So now the data is going to be below, which is in the body of the packet. DNS, and DNS stands for Domain Name System. I explained DNS earlier on how we would use the root, the parent, and the child. So just to briefly review that, if you're looking at google.com, right, the root would be the .com. The parent domain or the primary domain would be google.com. And then if you have any child, so for example, if they have a child domain, right, that would go in the front. And when you do the practice lab, you also see this in their domain. So you're accessing the child of the practice lab. You're accessing the domain or the network. That's the child of the practicelab.com. So what you see here is an illustration on how systems are connected to the domain. We are the end user here, and the end user would visit an example.com. It would go to the DNS root name server. It's gonna go to the .com, which is the root. It's gonna also resolve for example.com at the server level. And DNS uses port 53. Then what it would do is it's gonna send back after the resolution, it's gonna return that to the end user system. Now the web server is down here. That's going to be connecting to the DNS, and that web server is going to service the page to the end user system where that web page will be open for the site. Okay, so This shows you a little bit of the process behind connecting to the DNS and the web server. Important to know when you work with DNS in the labs, you would find that when the DNS is established, it holds some of the records. It's going to use this record to reference IP address for the lookup. So when the user type in example.com, it's going to use the A host record to reference the IP address of the server. The quadruple A record, it holds the host name and the IP version 6 address. So same functionality as the A host record, but the quadruple A record use IP version 6 address. The pointer record, or the PTR, it is the opposite of A. That would be for reverse lookup, where we can look up an IP address to a host name, to the server information. MX is used for Microsoft Exchange or Exchange in server. This allows you to connect the service to the actual DNS and also set up for Active Directory. So when the user authenticate, they're able to access their mailbox on the server for mail exchange and also tie with the domain. CNAME is used for alias recognition. This allows us to identify the system with multiple names associated with one IP. So you can have one IP address and you can have multiple names for that system. SOA record is used for zone settings, and this allows us to set up the time to live setting for the cache connection for the user to connect to the domain. The DNSSEC, which you see in the lab, this is Domain Name System Security Extension Suite. It is an extension of DNS. This one elevates the DNS service by adding digital signature for each record to provide data integrity. And so when you use NSLOOKUP command to troubleshoot DNS issue, you will see the DNS information or the DNS role in your network environment. We would use this command to verify DNS as well. So in the case where it's not able to resolve, we wanted to check using NSLOOKUP. In Linux, we would use the dig command, and dig command is able to find information about the DNS. As I mentioned, that ports is a number, a numerical value that's assigned by IANA. For the register port, that's going to be 1024 to 49 and 151. Dynamic and private port can also be used 49 or 152 to 65 or 535. The server ports is followed by the symbol after the URL. The client ports starts at 49 and 152 and increment up to 65,535. IP and ports are used in source and destination for TCP IP based services. So all the things that we're using to connect ourselves to the network and the internet refers to IP address and port number for all our services. We would use the port for blocking or filtering with firewall, with security systems, and also our router, like on your wireless router at home. So you can whitelist on the router by allowing certain type of services through the port and certain type of system connecting through using IP. Now, the simple network environment, you would see the system is connecting to a switch, which can be managed or unmanaged. A managed switch means that we can log into that switch, and that switch would have an operating system, and it would have a command line for us to be able to configure specific ports, specific services. And some switch would function at the low level, which it's just going to switch using MAC addresses to transport packet back and or data frame back and forth. And other switch would have layer 3 or higher in the OSI layer, where it would be able to route, it would be able to transport, and it operates at a higher level. So in a voice over IP network environment, you would see a layer 4 switch. In some part of the network in an enterprise environment, you would also see a layer 3 switch being utilized, where it also needs to route for subnet reason. So we can implement MAC address filtering in a switch, and we can do that for wireless routers and some of the router that has this feature, but for the switch in general, we would use that to filter physical address. So if you don't want a certain system connecting, you can block the MAC by filtering blacklisted, or you can only allow a certain system by whitelisting. Now in our network environment, we wanted to protect the physical switch, and we wanted to secure it, perhaps locking it in certain areas, especially for the rack, which contains all the network appliances and security appliances. We wanted to control the physical port connection on the switch, so that would be established through configuration. You can disable and enable certain port. So for a 48 port switch, we can enable 40 ports and disable the 8 ports that's not used. We can also prevent looping or bridging connection to another switch if it's not needed. Meaning bridging means that we would connect one switch to another switch to expand our network. And looping, that we would come back, we would route the frame back to that exact switch. And in some form of physical attack, they would try to connect their systems or another appliance to the actual switch, or to circulate the traffic back to that switch by forcing looping. So in flood attack, MAC addresses would be used as a target for floods, and it would overload the switch with different MAC addresses associated with a certain physical port. So you would sometimes see this happening with switch, and we wanted to make sure that we configure and protect our switch logically and physically. Now, some switch would have the implementation of a feature called Floodguard, and Floodguard would protect flood attacks. It would limit the number or the amount of memory or the RAM that would be used to store the MAC addresses. Router is used to route traffic or packets from one network to another, or in some cases, when it's internally used, they would segregate the different subnets by using layer 3 switch or a router. The routers don't usually, we can set it up where it doesn't broadcast, such as for the wireless router, we broadcast SSID if it's not needed. And there are different types of router, including gateway router, and gateway router would be used, or sometimes called edge router, that will be used to connect one network to the external network, like your internet service provider. So router often would contain access control lists known as ACLs. It's used to implement and identify traffic. We can set route for specific route, especially if you are protecting essential data for organizations, or if you wanted to protect traffic for a certain system. And routers only use IP addresses on the network. It also would be able to filter and enable specific ports. And ports would correlate to the protocol and the services that would be allowed or disallowed on that particular route. We can set up implicit deny, which either allow or deny certain type of traffic. So when we set up implicit deny, all traffic isn't implicit allowed is denied. Basically, you're whitelisting here. And ultimately, in security appliances and network appliances, we wanted to make sure that ACL is set up. And to prevent spoofing, we wanted to allow or block IP addresses, especially in the router. And on the switch, we want to allow or block MAC addresses to prevent MAC spoofing as well. So below the router information, I included a picture of what a bridge would look like. Sometime we can use a switch to bridge, or in other cases, they would use wireless access point or a router to bridge, depending on the layout and the layout of the network or the topology of the network. Another term that you should know is aggregation switch, and this is used to connect multiple switches together. It's used for bridging, and this is often used on a rack or across the network. Firewall can be an appliance firewall where it's an actual physical system. Sometimes you would see a firewall as a software, which we call that as application or soft-based firewall. And firewall is designed to filter incoming and outgoing traffic, or sometimes firewall should be used internally to filter ongoing traffic inside the network. So host-based firewall, as I mentioned, that would be for specific hosts, and it's usually installed as an application. Application-based firewall is a software that would filter and log traffic. So all security appliance would generate a log where you can refer to IP address, MAC address to be able to identify specific system on the log. Network-based firewall control incoming and outgoing traffic for the network, and you can implement stateless rules, which pertains to permissions, control, sources, destination, ports. So source and destination pertains to IP address, port number would be for port configuration, and permissions, we can set it up for how that system would have specific access to certain part of the network, such as database, data transfer, network shared drive, etc. Stateful firewall would inspect and make a decision based on the context or the state of the traffic. And some firewall, more advanced firewall, would have behavior based, so it would establish a trend analysis and automate that to understand or establish the rule for your common normal behavior in the traffic in the network environment. DMZ stands for Demilitarized Zone Buffer between private and your private network and the internet, and we want to put the web server on the DMZ along with an application firewall or some form of firewall that would protect your web environment, because entering from a public space, which is everything from the internet, that should go into the DMZ, and your DMZ should be the buffer zone before your network. You would have an edge firewall and also internal firewall along with intrusion detection system that's internally and intrusion prevention system at the edge. We will talk about more network layout and how to design a network with security in mind in the later class when we implement some of the solutions for our security class. Next, you need to watch the lab videos where I go over the lab procedure for Unit 3 If you have any questions, please contact me. Thank you for watching this video.